Let's take some good notes as we review linear equations. Our first example, you're putting up posts for a new deck. Local code requires the posts must be buried 3 feet in the ground, plus another 4 inches for every 1 foot of post that is above the ground. So every local place has a different code for this depending on how deep the ground freezes, because you want it to be below freezing line. But then also, if you have a super tall pole, obviously you'd want to bury that a little deeper. So that's what this is talking about. The first thing that stands out to me as a trained math teacher is that 4 inches for every 1 foot of post. I read that as 4 inches per foot. And whenever I see a rate like that, miles per hour, whatever it is, inches per foot, I think of slope. So I would make a note that the slope will always be considered a rate of some sort. Another thing I'm noticing here is that we're talking feet and inches, so probably just to save confusion, we should convert that to either just feet or just inches. And I'm seeing kind of smallish numbers on our graph, so I think we're just going to convert everything to feet. So instead of calling that 4 inches per foot, what's 4 inches in feet? Is that 1/3 of a foot? That's a little awkward now because now it's 1/3 foot per foot, but we know that the 1/3 of a foot is how much deeper we want to bury, and the bottom foot is the above ground feet. We'll talk more about that. I thought a picture would be helpful to help us understand what's going on here. It says on the sheet, write a linear equation giving the depth a post must be buried in order to leave X feet above ground. So again, the taller the post is above ground, the deeper you're going to need to bury it. So maybe it would just be smart to think about a few examples before we try to start making fancy equations and things. So maybe one thing we could say is, what if X was equal to 3 feet? That means that we want a post that sticks out above the ground by 3 feet. What would Y be? What depth would have to be buried under the ground? All right, so in the problem it says that all posts must be buried 3 feet in the ground, so it's definitely going to be 3 plus another 4 inches for every foot that's above the ground. We converted that 4 inches into feet, so I'm going to bury that another 1/3 of a foot for every foot that was above the ground. So can you make sense of that? 1/3 times 3 would be 1. So a 3-foot post would have to be buried 4 feet under the ground. The 3 feet that's required just as a baseline plus 4 inches per foot. And that would be 4 plus 4 plus 4 in this case, because we had 3 feet above the ground. Let's try another example, see if we got this. So if we wanted a post that was sticking up 4 feet above the ground, what depth would I have to bury it? I'm always required to bury 3 feet plus that 4 inches per foot that's above the ground, or 1/3 of a foot for every foot that's, and we have 4 feet above the ground, right? So that'd be 1/3 plus 1/3 plus 1/3 plus 1/3. That would be 4 thirds that I have to add on to that baseline of 3. And if we were still thinking in inches, 4 inches for each of those feet, that would be an extra 16 inches. 3 plus 1 1/3, that would be 4 1/3, yeah? So it'd be the 3 feet plus another 16 inches would be 4 1/3 of a foot. And like I said, the more posts sticking up above the ground, the deeper you want to bury it. Okay, just one more. What if we wanted a 6-foot post? How deep would that have to be buried? the 3 standard feet plus, for every one of those 6 feet, we'd have to include an extra third of a foot, or an extra 4 inches. So an extra third of a foot per foot above ground. And 1/3 times 6 is 2, so that's an extra 2 feet. 6 feet, 4 inches per foot. That's an extra 24 inches, so that comes out to a total of 5 feet buried under the ground. I was thinking of just plotting those points on this graph. Let's get those axes labeled so we know what they actually stand for. The X stands for the above ground distance. And we're measuring that in feet, yeah? And then the Y-axis stands for how much of the post is below the ground, the depth into the ground. And we also put that in feet. So let's plot those points. I figured out that a 3-foot post would have to be buried 4 feet deep. And a 4-foot post would have to be buried 4 1/3 of a foot deep. 6-foot post, 5 feet deep. And it is looking nice and linear. Might as well draw that line. All right. What do we notice about this line? The first thing I notice is, remember how I was talking about the rate is always going to be the slope? See how it does go up 1/3, up 1/3? You could also think of this rate as 1 foot buried below the ground for every 3 feet that you have above the ground. Both of those say the same thing. So for every 1 foot of burying depth, we would be able to increase by 3 feet above the ground. I really feel like we're ready to write a y = mx + b here. First of all, because we totally know what the slope is. The slope is that rate. And that slope, we did convert it over to feet, is 1/3. And what is b? Well, from my picture, it's looking like the y-intercept seems to be crossing at about 3. Would that make any sense? And actually, if you look back at these calculations we did, do you see how we were actually doing 1/3 times x plus 3? 1/3 times x plus 3, 1/3 times x plus 3. And what was the significance of that 3 every time? Why do we start with a 3 every time? It's because that local code, that's the baseline number of feet that every post has to be buried. Again, I'm going to ask you to interpret the m and the b all the time, so let's write that out again, what those two values represent. That 1/3 stands for 1/3 of a foot buried per foot above ground. Or you could say 1 foot buried for every 3 feet above the ground, just depending on how you want to write that. And then this 3 over here, this 3 is definitely just going to have the same label as your y value, and our y values are in feet, and that 3 does stand for a y value. It stands for that baseline depth that we bury all posts below the ground. It says here that we need a 4-foot tall post and a 6-foot tall post. What are the depths to which you'll need to bury each post? Well, we kind of already figured those out, right? Had we not figured them out, we've got a nice equation that we could plug those into now. we know that our 4-foot post has to be buried 4 1/3 foot. And our 6-foot post needs to be buried 5 feet. And so you need to plan ahead if you're going to the store to buy the post. You can't just buy a 4-foot post and a 6-foot post. Since we're burying a bunch of it, for that 4-foot post, we'd have to buy a long enough post that we can have 4 feet sticking out and 4 1/3 feet below the ground. So we would actually need to buy a board or a post that is 8 1/3 feet long. And the same thing for our 6-foot post. Since 5 feet have to go below the ground, we're gonna have to buy an 11-foot post to make that happen. Another thing I thought would be worth talking about is maybe domain and range. I didn't actually write that out, but let's think about it. Domain again is the X, and X stands for how far above the ground we're allowing. Domain again is the X, and X is standing for how much of the post is sticking out above the ground. So what would be the smallest post you would have? I suppose you wouldn't really have a 0-foot post, but maybe we would write 0 and say anything bigger than 0. So 0 wouldn't be included because that wouldn't even be a post. And then how big could we make our post? I don't know, maybe the airport has some sort of restriction on that, but maybe that's all we would need to write. In fact, it would probably make a little more sense to write that just as X is greater than 0. And then the range. The range is how deep we're burying these posts. And every single post is going to be buried at least 3 feet deep. So I'm going to say 3. And should we include the 3? I guess it's only going to be legitimately 3 foot deep if the post were 0 feet tall above the ground. So I don't think I would include that. It's always going to be 3 plus just a little bit at least. And remember that these are Y values. And is there any max on this? Is there any maximum depth that I could bury a post? And I suppose geologically there is some sort of maximum depth we'd be able to dig, but I don't know what that is. So I think we might just leave this as Y is greater than 3. There wouldn't be another value to put as a cap on that unless we talk to a geologist. So I'm going to say that the domain is X greater than 0 and the range is Y greater than 3. And so probably I shouldn't have drawn that entire line. Probably I should have cut it off with an open circle right here, right? Because I didn't want to actually include a 0-foot post buried 3 feet deep. So this model is really just good for this part of the graph, for when we're talking about positive values. Here's another example that's going to teach us a lot about what we need to know. It says a certain brand sells their televisions for $147 for a 42-inch and $188.40 for a 60-inch. And you know, when I read that, I don't see a specific rate at this point. Like, had they told me how many dollars per inch or how many inches per dollar I could get, I would have been like, oh, that's my slope. But I'm not seeing that this time. More so, I'm seeing sort of like ordered pairs, like this goes with this, and this goes with this. That almost is probably going to give me 2 X comma Y values. All right, consider the prices and the measurements. Which should be the independent, the X variable, and which should be the dependent Y variable? So that's just a little bit of vocab, independent variable and dependent variable. And that just means that, you know, this is kind of independent. We choose a blank, and that determines our blank. This is dependent upon what we choose for this. And so would you say that the size of the TV tells us how much to charge, or would you say that how much they're charging tells us the size of the TV? And in some ways that maybe could go either way, but I think when a company is pricing things, they're probably saying, okay, well, we want to make a 42-inch TV, how much should we charge for it? So the price of the TV depends on how big it is. Another way of saying that is that the size of the TV determines our price. And so when you get another problem like that, if you can phrase it in this way, the price depends on the size, that means we would be saying Y depends on X. And if you said it this other way around, the size determines the price, that independent size will determine the price, which is dependent upon that size. So either Y depends on X, or you could say X determines Y. That's another way of just talking about what independent and dependent variables mean. Assuming the relationship between the quantities is linear, write an equation that gives Y for values of X, then interpret each constant in the equation. Love to interpret. And you know, like I was saying, I was thinking that these would stand for ordered pairs, and now I've decided which order I want to put them in. I want to go X, then Y, always, and in this case we're talking about size, then price is what we've determined. Makes the most sense, probably. And so they've already given me two ordered pairs. I've got a size of 42 for $147 and a size of 60 for $188.40. So watch for that in your problems and see if they're actually trying to give you any ordered pairs. We'll definitely be able to use that. Might help to set up this graph just so we can get a visual look at what's going on here too. And I want to get up to at least 60 inches on this graph, so I think I could go every 2 is 10 inches. And then I know I want to get up to $188 at least. So I think I figured counting by each square is $20 should work out. And then let's just do our best to plot those ordered pairs. It's not going to be super accurate, but this is just to help us get an idea of what we're looking at. 42, 147, and 60, 188-ish. And you can imagine if they're charging a constant dollar value per inch, this would continue to be linear. And what do they want us to do? They want us to write an equation for that line. Let's throw it on our y equals mx plus b and figure out what we know. You know, they didn't tell me a slope, like $1 per inch up in the problem, but we can definitely calculate a slope if we have 2 points, right? We can use the slope formula. So we saw a rise over run, a rise of 41.4. And remember that rises stand for dollars. And we saw a run of 18 inches. I'm just going to write that. I did 41.4 divided by 18, and it comes out to 2.3. So right now we're sitting at y equals 2.3x plus b. We're halfway to our goal of writing that equation. I just need to figure out what b would be. And if I were to try to draw that line, it looks like maybe it'd be hitting right around the 50 mark, do you think? But that's totally just an estimate. So there must be a mathematical way of calculating that b value exactly. And that technique, which we've seen one more time before, is temporarily plugging in an x and a y that we know we want to have on that line. And so we could choose either this xy or this xy, and that would help us figure out what our b stands for. I'm going to choose the one without the decimals. Make sure you get them in the right place. Our y value is the price. Oh, not bad. I thought it was going to be 50 and it was 50.4. So mission accomplished now. We can write the equation of the line because we calculated the slope. And we figured out what that y-intercept would need to be. And now we can use that to predict how much our TV should cost, right? Like if we want to buy a 100-inch TV, we would just plug in 100 and that would tell me how much I should expect to pay. Or if I saw a TV for $500, I could solve for X and see how big of a TV I should be getting for that price. And by this point, you know I love for you to interpret what those two values stand for. So going back, our slope, remember our slope is always a rate. And do you remember how I'm using these labels? My Y value is measured in dollars. I really like to use those labels to figure out what I'm talking about. And my run, my X values, are measured in inches. So that really tells you what the label should be for that 2.3. It should be dollars per inch. And so if I were to write that in a complete sentence, I would say something like, I should expect to pay an extra $2.30 per inch when I'm buying a TV. And I also included that word increase. There will be some examples where we have a negative slope, and that would talk about a price drop maybe. But that's important to mention too. And what does that B value stand for? Again, it's going to help to think about, okay, where is it on the graph? It's a Y value, right? It's the Y-intercept. Y values are all dollars, so it definitely has something to do with $50.40. And then do you remember that fact that Y-intercepts always have an X value equal to 0? That can be a huge clue too, because our X value stands for the size of the TV. So we could say when the size of the TV is 0 inches, the TV will cost $50.40. And I suppose no matter how big you make the TV, there's some parts that you have to use just as your baseline, right? I think I understand why they call that a B. That Y-intercept seems to be sort of a baseline. So hopefully that helps. I tried to give you a lot of tips, and you should be writing all of this down because most problems will look like one of these two examples. Remembering that you're going to either be looking for a rate in the problem, or maybe some ordered pairs, or maybe even both.